Hello, uh, with this video I will show you something very interesting about the Ulam spiral, which starts from 0, not Ulam spiral which starts from 1, but from 0. This is very important. If I choose this version of my program, which draw some dots on the screen, you can see blue numbers which are normal numbers, red dots with which are twin prime numbers, green dots which are prime numbers, and there will be two rows and two columns of dots in which there will never be prime numbers, one column in which there will never be prime number, and one line, one row in which there will never be prime numbers. I take a screenshot. You can see the rows and the columns. So in these two rows you will never see prime numbers. Also in these two columns, the starting number is here. This is 0, 1, for me 1 is prime number, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 13, and so on. So in these two columns there will never be prime numbers. In this row there will never be prime numbers, and and in this is blue. I do a mistake. In this column there will never be prime numbers. This is a cross. There is another cross formed by the four diagonals starting from the center. So if I choose orange, blue, you can see this column. You can see the 0 is here, so, and also this. Another is here, this is 0, and another is here. A very large diagonal here and diagonal here, a very large row here, and a very large row column here. If we take the program which draw the numbers, now we can analyze the numbers which are in the diagonals. And 0, 1, 2, 3, 4, 5, 6, 7. I take a screenshot of this diagonal. Okay, I can draw some circles. So I have 1, 9, 25, 49, 81, this number, and so on. This is the progression of odd numbers to the power of 2. So we have 1 to the power of 2, 3 to the power of 2, 5 squared, 7 squared, 9 squared, 11 squared, 13 squared, 15 squared, and so on. Another interesting diagonal is this, from 0 to the upper left. I take a screenshot. Okay, like before, I have to 0, 4, 16, 36, 64, 100, 144. And these are the even number to the power of 2. 0 to the power of 2. This is 4, is not written very well. 2 to the power of 2. 4 to the power of 2. 6 squared. 8 squared. 10 squared. 12 squared. And so on. And it is very interesting for me. Now we will see this number in this diagonal. Okay, if I start from here, we have the only exception of 2, like as a prime number. But again, after there will never be prime numbers. So we have 0, 1 for 2, 3 for 4, 5 times 6, 7 times 8, 9 times 10, and so on. Very similar is this diagonal. So we have here 0, no, this no. See, yes, this. We have 0 for 1, 2 for 3, 5 for, no, 4 for 4 times 5, 6 times 7, 8 times 9, 10 times 11. I will put in the description these two versions of my program, and recently I have improved the program with the square numbers. And it is a very small speed in this program, and I have put this autosave image, so you can start from a number. We start from 0 now. I put autosave image, and the program automatically stop at the end of the animation, save the image of the canvas, increase the number, so 0 comes 1, and save automatically. So if you let your computer works for an hour, you will have 100 images perhaps, and then you can see these images like slides and see the pattern of prime numbers which moves in the screen. I can do an example. This is from 0. There is a beep when it stops automatically. Automatically he has saved the image with this name, canvas image and the starting number. So you can have the images ordered in the right order, and it is very important. Now the images is canvas image 1. You can choose the color you want. Now it starts from 3. In the images, very important, you could find the information about the starting point in the images in the upper left. Okay, now I stop. If I go to download, I can see all these images with the arrow keys. I can see the movement of these images. Okay, it is very interesting. If you have 100 images, it is very interesting to see how these numbers move in the canvas. Another thing is that you have this letter in white because you can use also your keyboard. S to start and stop, V to save the image, C to clear the canvas, autosave, or you can activate or deactivate autosave. And also 1 and -1 are in white because you can use plus and minus to change the starting point. I've improved also the program because it is there is the possibility to start with 100,000, 1 million, 10 million, 100 millions, and 1 billions of starting number. In my computer, 1 million is very it takes a lot of time to generate images, but if you have a very good computer, you can save your image from 1 million or 100 millions and so on. I will put in the description of the video also this program, and I hope that you will find it interesting. Thank you very much for watching my video.